Hey y'all, we're back with chapter 11, and we are now going to move on to area of a trapezoid, rhombus, and kites. So we'll look at all three and kind of where they came from. So let's start off by looking at the trapezoid. And remember from the last section, we looked at the height of our squares and our triangles. And now we're going to look at our height of our trapezoid. So the height, where we can find that, will be the perpendicular distance between its bases. And if you recall from the sections before, where the bases are, remember a trapezoid has a pair of parallel bases. So we can refresh our memory a little bit on a trapezoid and the properties of that. So we will say that this will be our base, and this will be our base. And the height is the perpendicular distance between the two bases. So again, remember, the perpendicular distance is the shortest distance. So that's what we're going to use when we look at area. We also have the two sides of our trapezoid, but since it's not perpendicular, we're not going to use that. So we don't necessarily have to have that distance. So that's what two things we're going to look at to find the area. So looking at theorem 11.4, the area of a trapezoid is 1/2 the product of the height and the sum of the lengths of its bases. So we need all three things to look at the area. So we can write that as 1/2 h times b1, base 1, plus base 2, so the average of the bases. And you're thinking, well, where does this come from? So the area of a trapezoid comes from, if you recall, our mid-segment from before, the two midpoints of the sides. Well, if you drew, let's say, a rectangle through those midpoints, you would notice that the rectangle has an empty space here, but our trapezoid has the outer space. So that kind of fills in that space up above. So that's kind of where they get the area of that trapezoid. And remember that the bases are parallel, so we can write it as 1/2 height times our base 1 plus our base 2. So, if you need to pause it or restart it to keep writing, you may. So let's go down to our first example. So for beavers, to prevent them from damming a drainage pipe, the trapezoid-shaped fence shown is placed at the pipe. Approximate the area of the enclosed fence. So remember, if we have a trapezoid, let's rewrite the equation that we're going to use. So 1/2 height times b1 plus b2. Alright, so we know what we need. So let's look for our height. And remember, the height is the perpendicular distance between the two bases. So we would say our height is 8 square root of 2. The length of the bases are the parallel ones, so 16 feet and 8 feet. And again, all we have to do is plug it into our equation that we have already done. So we would have 1/2 times 8 square root of 2. And then we are going to add our two bases together. So let's do that out here. So 1/2 times 8 square root of 2 times, what is that? 24. And then we're going to solve, and we can approximate that as 136 square feet. If you need to recall, I would have done the 1/2 times 24, so 12, and then put in my calculator 12 times the square root of 8 And if you even want to simplify that more, you do 12 times 8 and then leave that square root of 2. So 12 times 8, square root of 2. And you can get approximately 136. So another example would be over here. We'll quickly set this up. You know that your 4 is perpendicular, so you can also call that your height. So again, our trapezoid area equation will be 1/2 h times our 2 bases added together. So remember, 6 will be our base, 8 will be our base, the 2 parallel. So our area equals 1/2 times 4 times 6 plus 8. And you can get your area, and remember it will be units squared. Don't forget that squared. So again, if you have questions, you can come ask me at a later date, and you can pause this video whenever you may need to. Let's keep going on. So let's move on to our rhombus and our kite. So to find the area of our rhombus and our kite, let's start with our rhombus. The first is we're going to take 1/2 the product, so we're going to multiply the lengths of its diagonals. So we would say diagonal 1 times our diagonal 2. And remember, our rhombus diagonals are perpendicular. If you see a common theme, we're always looking for that perpendicular spot. So we can say also for our kite, the area of our kite is 1/2 the product of the lengths of its diagonals. Again, multiplying our diagonal 1 times our diagonal 2. And notice it's the whole length of the diagonal, not just part of it. So in words, if you haven't noticed, I always like to put it in words. Our diagonal 1 times our diagonal 2. I ran out of room there. Alright, if you wanted to review where that came from, if you draw a rectangle around your rhombus, and this will also work for your kite, and then you draw the diagonals, well, you can first tell that's a rectangle. And then if you drew your diagonals of the kite or your rhombus, you notice that you make 4 squares. And we are only half of each square, so that's where we take, instead of taking our length times our width, and then we're going to take 1/2 of that. So that's where we get our formula from. So let's go down to example 2. Again, remember that our diagonals of our rhombus and our kites are perpendicular, and that's what we are trying to find. So we want to find the area of the rhombus if we're given the 2 diagonals. So find the length of each diagonal. The diagonals of the rhombus bisect each other. That's another characteristic that we learned. So if we look at QT, we know that QT is equal to TS, yes, of course, and PT is equal to TR because they bisect each other. So that's a characteristic we need to make sure we memorize. So QS equals QT plus TS. So we would say 8 plus 8 would give me my length of my diagonal 1. And then we can go to PR, and we can say that will equal PT plus TR. So 11 plus 11 gives me 22. That would mean my diagonal 2. So find the area now that we have both. Again, our area equals 1/2 of our products of our diameters, or our diagonals. So we would say 16 plus 22, what we found above, and we would get 176. And since we're dealing with area, we can say centimeters squared if you want to write that. Alrighty. And another example quickly. Our formula, what is our formula for a kite? Again, same as a rhombus, it would be area equals 1/2. The two diagonals. So I would say my area equals 1/2 of 6 times 14. If I do that together, I will get 42 inches squared. Don't forget that inches because that will probably be counted off, knowing me. So, moving on to our checkpoints, I have worked them out. I got some feedback that I really liked, so if you guys ever have any feedback, let me know. But here is they are worked out, so you can pause the video and do them on your own and then check your answers. But we'll keep going to example 3. We need to find the unknown measure. So one diagonal of the kite is 2 times as long as the other diagonal. So that's where they get the 2x and the x. And then we know our area equals 56.25 square inches. So we're going to draw and label our diagram. Let x be 1 and twice as long as the other, so we can label that as 2x. We know our formula that we should write down, so let's just fill in the blank. 56.25 equals 1/2 of 2x and x. I'm going to bring it down. 56.25 equals 1/2 of 2x squared. Remember our algebraic, that 1/2 would cancel. So I'm going to take x squared to equal 56.25. To cancel, I'm going to square root both sides, and I approximately get 7.5 as x. So one of my diagonals is just 7.5 inches. The other, don't forget that step, I have to take times 2, and I would get 15 inches. Alrighty, let's do this example quickly. We'll look at our formula for a parallelogram or a trapezoid. 1/2 height, and then I'm going to add my base 1 plus base 2. And I have my area that they gave me, 300 equals 1/2. My height would be 20, and then my bases together, and you can work that out to find x. And last one here, looking at our yard. Each square represents 3 by 3 meter. We want to find the area of our really awesomely shaped backyard. So looking at base 1, BC, I know that this is 18, and this is 9 because I'm moving horizontally. I'm moving my x's, so I would say 18 minus 9, and I would get 9 meters for my base 1. Then looking at AD, I have 24 and 8. So I'm just going to subtract those because, again, I'm moving my x's are the only ones that are moving. So I would get 21 meters as my base 2. And then I have to find my height. And now I'm moving or vertically, so my y's are changing. So I will be at 21 minus 6 gives me 15, and then I'm just going to plug it back into my equation. 1/2 of my height and my 2 bases added together, and I would come up with 225 square meters. Alright, again, I have worked out your checkpoints. You can stop here and look back, and do your checkpoints and look back at the answers and see if you can get the correct ones. Again, if you have any questions, please let me know. I hope you have enjoyed our time together for section 11-2, and I hope this is helping out. We'll continue with this on Friday. Have a great night.